Hi guys, so today we are going to be discussing absolute value and step functions. So yesterday we did a very intro to absolute values, just like solving for simple operations. Today we're actually going to make these absolute value functions and step functions and be able to graph them. So down here you can see your learning target. Says I can analyze functions that include absolute value expressions, and I can graph and apply step functions. So our vocab here, we have absolute value. This is the distance from zero on the number line. We talked about that yesterday. These quick little examples here should be pretty easy. Find each of the following. The absolute value of positive 3 is 3. The absolute value of negative 2 is positive 2. And this absolute value, remember, you want to solve first, so negative 5, and then do the absolute value. So real quick, if you were not here on yesterday's intro lesson, when it says it's the distance away from 0, hopefully you recall distance must be positive. So this first problem, 3 is 3 units away from 0. Negative 2 is 2 units away from 0. Distance is not negative. That's why it is a positive 2 away from 0. So now example 2, we're getting into the functions. This is what the graph of an absolute value function looks like. This is what we call the parent function. And then we can change it from here. So we're going to start with just a table of values for all of these. That means you plug in your information, you solve, just like we were doing yesterday. You plug in a number, you solve. So for example, if we have the x value of negative 2, when we solve that, our y value is positive 2. If we plug in an x value of negative 1, our y value is positive 1. Hopefully you guys see how I'm plugging it in. I'm kind of working backwards compared to the table, but this guy over here is my y, and obviously I'm plugging in my x. So I continue this, and notice when I have my coordinates then, that I have the coordinate negative 2, positive 2, and negative 1, positive 1, and the coordinate 0, 0, and 1, 1, and 2, 2. So it makes a V shape. Absolute value functions do make V shapes. So it asks us, what is the domain? Remember, this is your x values. And our x values, these guys, do continue forever. So this is all real numbers. You can also write it as like a fancy R. That means all real numbers. The range does change, though, from our linears. Most of our linears were all real numbers for both the domain and range. If you look at your y values, though, that are these values up and down, our range, they stop right here. Nothing is in our range below 0. So you can say all real numbers with y values greater than or equal to 0. Okay, you don't have any y values smaller than 0. They're all positive. So that is what your range is. There's other ways to write it too. That's only one way that you can write your domain and your range, specifically your range. But it's totally valid. So if we're going to evaluate for certain things, this is just seeing what our y value is when we have an x of negative 1. So x of negative 1 is here. We go up to 1, so our y value is 1. You can also just plug these into your equation if you want and find the absolute value of it that way. Or you can look at the graph. So over to 4, up to 4. We go over 0, well, we go up 0. So those are our evaluations. This example here gets a little crazier. Don't freak out. It's totally fine. It's just like what we did yesterday, except now we have to plug in the numbers. We're not just given the numbers pre-plugged in. So we have our function. I'm going to rewrite it over here. give us some workspace. I am going to plug in 2 for x. That's what this function 4 means. 5 for x and negative 5 for x. So let's do it. F of 2 is equal to the absolute value of 2 minus 2 plus 3. So that is 0 plus 3. So f of 2 is equal to 3. F of 5. We go ahead and plug this in. We get the absolute value of 3 plus 3, or 6. F of negative 5, we plug this in. Don't get too speedy with doing the absolute value. You get the absolute value of negative 7 plus 3, which is actually 7 plus 3, or 10. And we're going to call this page 1. Okay? So we do have more notes. We're going to go on to step functions. That's the very intro to absolute value functions. You'll be able to do those more and more readily as we keep practicing. And I'll give you some other tips and tricks that you can use as well. But for step functions, a step function is a function whose graph forms the shape of a staircase. It is also called a piecewise function. It's one specific type of piecewise function. There are a bunch of other ones, but we're just going to do step. So remember, f of x, which is the same as y, is equal to any number, creates a horizontal line. Okay? That's where we get the step idea from. Also recall, an open circle means that the point is not included in the graph, and a closed circle means that it is included. So for example, when we evaluate these, we have the x value of negative 5. So we go over negative 5. I'm just going to put a mark right here just so you see where I am. We go over negative 5. That mark doesn't mean anything. And then you try to see where your y value is on this step function. And it is down here at negative 2. So we say that when x is negative 5 in the step function, y is negative 2. Now we go for x is 0, and we see that y is at 1. Then we go over where x is 2, and we see that y is still at 1. So guys, you're just evaluating, you're finding how far over you are going, and then seeing where that line is for the y values. Now, this next one we do have to draw. We are going to evaluate each of the following using the step function and write a corresponding ordered pair, then graph the function. So, I'm going to actually graph first and then use the graph to decide where all of my points are. I find that easier because these I know are all just like y equals 1, and here is my domain for that. So I know at y equals 1, it includes the number 5. So I'm going to make a horizontal line at 1. And then it goes to 0, but it does not include 0. So it includes negative 5, but not 0. So there's one of my steps. My next step is then at y equals 3. It includes 0 and then goes to 4, but does not include 4. That's what this tells me. Then my next step is y equals 5. It starts at 4, it does include it, and then it goes to 8 and does not include it. Oh no, it does include it. Gotta look at those signs. So it does include 4, does include 8. And there's our step function. That's basically how you plot those. So now I'm going to see where x is negative 5. My y value is 1. You can use these guys. So like x is negative 5, y is 1. Or you can just look at the picture, which I prefer to look at the picture. But either way is totally fine. Where x is negative 3, y is 1. Where x is 2, y is 3. If it would help you, I can make a little mark there. X is 2, y is 3. X is negative 3, y is 1. X is negative 5, y is 1. So I worked backwards. Now we're at x is 3. So the y value is still 3. When we get to this 4, notice there are two kind of points. One is open though, so we actually skip up to the other one where it is included. So g of 4 is 5. And then when x is 7, y is 5 again. So that's intro to step functions. That is page 2. Now, the next 2 pages, these were going to be in-class practice. I am going to go through them really quickly. I'm probably not going to do a ton of explaining, but they will set you up to then work on the next 2 pages in your packet that are labeled homework. So I want you guys to try this homework. Also continue working on that Delta math I gave you yesterday if you have not finished it yet. So I'm going to go through these. You can follow along if you like, or you can look at the key on Classroom. Absolute value of 6 is 6. Absolute value of negative 6 is 6. Absolute value of 1 is 1. Absolute value of negative 5 is 5. Now we're going to have to evaluate for x equals 2 and x equals negative 1. Just remember, f of x. So this is x equals 2. We'll plug that in. Follow the order of operations like we learned yesterday. So f of 2 is 7. Solve for f of negative 1, and we get that f of negative 1 is 5. We're going to evaluate another function where x equals 2 and x equals 0. So g of 2 equals 0. G of 0 equals 2. Now, we haven't really done a ton of graphing like this, so this is good practice for sure. We're going to complete the table and then graph. So if you notice up here, these are actually the same functions, these two. So we're just graphing this. We did solve for g of 2, but they already had that here for us, and we solved for g of 0. We can fill in that answer, being 2. So I'm going to go ahead and solve for the other ones. I got to kind of squeeze in up here. So this will equal 4, f of negative 2. We already know f of negative 1 is 3, f of 0 is 2. We need to solve for f of 1. So we get that this is 1. Notice that the y values do count down, so you could probably have just guessed that. If we graph this though, guys, notice over negative 2 up 4, over negative 1 up 3, over 0 up 2, over 1 up 1, over 2 up 0. We're only making a line. So we need to actually do a couple more examples so that way we turn this into a V, an absolute value equation. So I'm going to keep going this way. I do know a little bit more about these than you guys, so I know which way to continue on. We'll actually be able to tell this more on our next lesson. But for now, I'll just tell you to continue on and find f of 3 and f of 4. So f of 3 is negative 1. F of 4 is 0. So notice it does change and start going back the other way. So we have 3, negative 1. We have 4, 0. Then there's something called an axis of symmetry. We'll learn about it later. You can just assume that this will continue upwards. So we had to find the vertex point, the change of direction, before we could just put our V anywhere. For this next one, we also need to solve, which is the same actually as this top equation. F of 2 we already found was 7. F of negative 1 we know is 5, so we need to find 2 more. So I'm going to plug in negative 2. So I get 7 here. And then I'm going to plug in positive 1. And I get 5. So now I can graph this. Negative 2 up 7, negative 1 up 5, over 0 up 3, over 1 up 5, over 2 up 7. Guys, these are just coordinates that I'm plotting. That's based on these guys. And then we've got a few more problems with step functions. So that's absolute value. We'll learn more about that on Monday. So we're just going to evaluate using the graph. These are pretty simple. We go over negative 4. We find where the graph is. So f of negative 4, the graph is at negative 3. At f of 2, the graph is at 1. F of 0, the graph is at 1. F of 8, the graph is at 7. Try the next one as well. F of negative 7 is at negative 6. Oh, sorry, it's a G. G of negative 7 is at negative 6. G of 2 is at 3. G of 0 is at 3. And G of 9 is at 5. I did not mark all of those, but this is where we are. Negative 6. Positive 3. Positive 3. And positive 5. So that's how I figured out all of those. Basically, they're just coordinates that are on our step function. From here, we're just going to choose some x values. So I'm going to choose some, put x coordinates in order from smallest to largest. I'm going to choose some random ones. And then I check to see where these are in the ranges. So x equals negative 4 is in this one. So our y value is 0. X is negative 1 in the same range, so y value is 0. Positive 1 is in this range, so 2. 2 is also there, so 2 again for our y value. And then for x is 5 and 7, our y values are 7. So I can graph these. I'm actually just going to use this piecewise step function to know where to graph. So I know y is 0, so a horizontal line between negative 4 up to 0. And then I know we have a horizontal line at 2 from 0 over to 3, and a horizontal line at 7 from 3 and including 7. And now I can evaluate these. So h of negative 4 is at 0. H of negative 1 is at 0. H of 0 is at 2. Make sure it is included. H of 2 is at 2. H of 4 is at 7. And H of 8 is off the graph. There are no points here, which means this is our first weird one. There are no solutions. And then we'll do the same thing with our last one here. I'm going to just choose some random x values because we can do that. I am going to choose them within the range though, so I don't get no solutions again. Looking within the ranges, if x is negative 5, y has to be negative 2. If x is 0, y also has to be negative 2 because it's within this range. If x is 1, y has to be 3. If x is 3, since it's in this range, y has to be 3. And if x is either 5 or 6, y has to be 5. And then we can graph it. I'm going to use the piecewise again up here. So I know I have a line at y equals negative 2 from negative 5 up to positive 1. And then I have a horizontal line from 1 to 4 at y equals 3. And then I have a horizontal line at 5 from 4 to 9. And then I can evaluate. So at x equals negative 3, y is negative 2. At x equals 1, y is 3. At x equals 5, y is 5. At x equals 7, y is 5. At x equals 0, y is negative 2. And at x equals 3, y is 3. So that finishes up our notes today. I know those are kind of long. You can hopefully skip through some things, follow along. Once you have finished these, I would like you to try this homework stuff. Should be relatively quick. It's exactly what we just did on the class practice page, just different problems to get some extra work in there. Make sure you really understand. Anyway, these are the next 3 pages in that packet I gave you guys yesterday. So you can work on these today. Have a great day.